In this video, we want to consider important ideas of step 2 and related problems from prestigious math exams in USA and British Mathematical Olympiad in UK. These are important ideas, and from each idea we will solve step 2, for example, problems. We work on that 2022 here. Then AMC problem for American mathematics competitions. Step 2 problem, for example, another idea, consider small example and induction, solving problems from BMO round 2, British Mathematical Olympiad, another idea. Step 2, 2022, ideas in areas perpendiculars. Step 2, 2022 problems and related problem in BMO. And AME, which is next level 2 of American mathematics competition, or I can say American Mathematical Olympiad, and the name is this for the last AME 2023, AME 1. And we test formula Newton sum problem from step 2 2021 and problem from Stanford Math Tournament 2022 from Harvard MIT Math Tournament. And next one, ideas in greatest integer function or floor or integer part. Step 2 2021 problem and AMC problem, PMO2 problem, PMO qualifying level problem, and again AME problem. Okay, so from each idea we want to solve related problems from different prestigious exams. If you want to solve more problems or want to learn another important ideas or want to prepare for step 3 or any other exam, as I said before, feel free to send message to my WhatsApp number in the description comments. Okay, so let's start from first idea, rearrangement and using telescoping rule sum product. And also another idea in polynomials, which is related coefficients, so much important idea, and so on, and finding closed form. Let's start with this problem of step 2, 2022. Step 2, 2022, problem number 2. A sequence UN, where n equal to 1, 2, and so on, is said to have degree d if un as a function of n is a polynomial of degree d. Part 1. Show that in any sequence un that satisfies un plus 1 equal to 1 over 2 times un plus 2 plus un for all n greater than equal 1, there is a constant difference between successive terms. Deduce that any sequence un for which un plus 1 equal to 1 over 2 times un plus 2 plus un for all n greater than equal 1 has degree at most 1. Okay, here let's write the main assumption. Un plus 1 equal to 1 half un plus 2 plus un. And we should work on difference between successive terms. So when we want to consider this thing, we should rearrange this and see successive terms means what. Successive terms means, for example, ui plus 1 minus ui. We should prove that it is constant. Here we should rearrange and reconsider this by considering this part. We multiply first by 2, then it will be 2un plus 1 equal to un plus 2 plus un. These problems are also useful in Olympiads, okay? And then we write un plus 1 as un plus 1 plus un plus 1 equal to un plus 2 plus un. And because we want to use successive terms, we move this to right, un plus 2 to left. So in next step, we reach un plus 1. Or let's do something else. I think it's better. Move this to right and un to left. So it will be un plus 1 minus un equal to un plus 2 minus un plus 1. Okay. So as you can see, we can say, suppose so, these two things are equal. We can say un plus 2 minus un plus 1 equal to un plus 1 minus un. So we know it is correct for any n. Now if you apply for this part, if you decrease, it is like an identity. Un plus 1, if you decrease n, minus un equal to un minus 1 minus un, if you consider un equal to un minus un minus 1, and so on. So we will see that what happens, un plus 2 minus un plus 1 equal to un plus 1 minus un equal to un minus 1. Similarly, you can decrease and decrease equal to u2 minus u1. And u2 minus u1 is a constant. We know u2 is what, u1 is what? It's a d. So, or let's consider it as C, the constant. Now the problem says what? First, prove that this part we proved, and then it says deduce that any sequence un for which un plus 1 equal to this, for all n greater than equal 1, it has degree at most 1. So let's check that. We can say, let's start because we want to find un. I say un minus 1 is C. Here un minus 2 minus un minus, let's decrease n by 1. It is similar to an identity because of this. Un minus 1, un minus 2 is C. Un minus 2 minus un minus 3 is C. And u2 minus u1 is C. Okay. Now, and the problem says it starts from n greater than equal 1. So terms will be cancelled alternatively. We call it telescoping sum or rule here. We have also telescoping product similar to that. So un minus u1 equal to what times c? 1 to n minus 1, n minus 1 c. So un equal to what? N minus 1 c plus u1. u1 is a constant. So we can say nc plus u1 minus c. It is another constant, for example, c1. So it is nc plus c1. So if you consider as a polynomial in terms of n, the degree is 1. Why the problem says at most 1? Because if c is 0, then the degree will be 0. Because this term will be cancelled. Okay. It was part 1. Let's solve part 2. It says the sequence Vn satisfies Vn plus 1 equal to 1 half Vn plus 2 plus Vn minus p for all n greater than equal 1, where p is a non-zero constant. By writing Vn equal to Tn plus Pn squared, show that the sequence Vn has degree 2. Given that V1 equal to V2 equal to 0, find Vn in terms of n and p. So first, let's solve first part. Here it says using this and show that the sequence Vn has degree 2. Okay, so if you write Vn as that, so Vn plus 1 equal to 1 half Vn plus 2 plus Vn minus p. And the other assumption is Vn equal to Tn plus Pn squared. And if you replace it here, Tn plus 1 plus p times n plus 1 squared equal to 1 half times Tn plus 2 plus p times n plus 2 squared plus Vn, which is Tn plus Pn squared minus p. Okay, so let's see what are the terms. First, we multiply both sides by 2. Then 2n plus 1, Tn plus 1 plus 2p. Here we write it as n squared plus 2n plus 1 equal to Tn plus 2 squared plus p. N plus 2 squared is n squared plus 2 times 2 times n 4n plus 2 squared, which is 4, plus Tn plus Pn squared minus 2p. Okay, when we multiply by 2. Now here, we have Pn squared, 2Pn squared, with 2Pn squared will be cancelled. 2p times 2 and 4Pn, it will be cancelled by 4Pn. And then we have 2p. Here, 4p minus 2p, 2p. So again, we can cancel this, and this. Then it will be what? It will be 2Tn plus 1 equal to Tn plus 2 plus Tn. And if you write it as Tn plus 1, if you divide by 2, Tn plus 1 equal to 1 half Tn plus 2 plus Tn. So as you can see, it is exactly similar as part 1. That it was un plus 1 equal to 1 half un plus 2 plus un. It is this. And we can use the previous part. It's to show that the sequence Vn has degree 2. And by previous part, we proved that Tn has degree 1. So it is, for example, C1, n plus C2. And we know Vn is what? Vn equal to Tn. The problem says from this assumption, Tn plus Pn squared, it will be C1n plus C2 plus Pn squared. So it is degree 2. Why? Because a leading coefficient P is not zero and non-zero constant. So we prove first part. Now it says given that V1 equal to V2 equal to 0, find Vn in terms of n and p. Okay, so let's replace. At first, we found this relationship for t, and we found un is what? Nc. C was what? The difference of successive terms. So, okay, so we want to use these things, and for example, we should find CC1 for here Tn. But first, let's use V1 equal to V2 equal to 0, and let's use the formula here. V1 is what? V1 is T1 plus P. V2 is what? Is T2 plus P times 2 squared 4P. And V1 equal to V2 equal to 0. Okay, so from this part, we conclude it is 0, so T1 equal to negative B. Because this one is 0, T2 equal to negative 4P. Okay? And T1, T2, so T2 minus T1, the difference that we said C. In previous part, C was the difference of successive terms. Which is C, T2 minus T1 is what? Is negative 4P minus P, which is C. So here, C equal to negative 3P. Now, the other part is U1. U1 here is T1. T1 is negative P. And we know the formula was what? N minus 1 times C, so Tn. N minus 1 times C, which is negative 3P, plus U1. Here, plus negative P. So it will be what? Negative 3Pn plus 3P minus P. So it will be negative 3Pn plus 2P. It is what? It is Tn. So let's check. If you replace n with 1, T1 will be negative P. If you replace n with 2, it will be negative 6P plus 2P negative 4P. Okay, so it is our Tn first. Now the problem wants what? Wants Vn. Vn is Tn plus Pn squared. Vn equal to Tn plus Pn squared. So Tn is what? Negative 3Pn from previous part plus 2P plus Pn squared. Okay, so if we consider from highest power of nPn squared minus 3Pn plus 2P. So let's, because it says find Vn in terms of n and p, let's only write this. Okay, V1, the problem says 0, so let's check P plus 2P minus 3P 0. V2 also 0, 4P plus 2P 6P minus 6P 0. Okay, so we've solved also part 2. Now let's solve part 3. For part 3, it says the sequence Wn or omega n, we can say, for example, let's consider Wn. Satisfies Wn plus 1 equals 1 half Wn plus 2 plus Wn minus a and minus b. For all n greater than equal 1, where a and b are constants, with a not 0, show that the sequence Wn has degree 3. Given that W1 equal to W2 equal to 0, find Wn in terms of n and a and b. You can try this part as homework. It's similar to previous part, or we can solve it together. So here, before solving this, if you want to solve, I should tell you an important point in, let me tell you, identity in polynomials. The idea is what is that if you have, for example, an xn plus an minus 1 xn minus 1, or a1x plus a0, if it is equal to bmxm plus bm minus 1 xm minus 1, b1x and b0 for infinitely many x, or also you can say greater than maximum of their degree for infinitely many x's, then m should be equal to n, and then here an bn, an equal to bn, the polynomials, all related things should be equal. and a0 should be equal to b0. It is so much useful in polynomial problems. We can solve many problems in also Olympiad by using this idea. And also we want to apply this idea here. Part 3, this one, it says this, and it says show that omega n has degree, wn has degree 3. So I say wn equal to, we should write degree 3. For example, we can say it is equal to a3n cubed plus a2n squared plus a1n, one way is this, plus a0. And then work on coefficients of this. See, can we find that something like this to satisfy this? So the first thing, it says w1, w2, 0. w1 is what? Is a3 plus a2 plus a1 plus a0 equal to 0. w2 is what? Is 8a3 plus 4a2 plus 2a1 plus a0 equal to 0. And here, if we consider wn plus 1, we can multiply it by 2. So 2wn plus 1 equal to wn plus 2 plus wn minus 2an minus b, minus 2b. And then if we replace with this formula, it will be 2a. Let's write wn plus 1 is a3n plus 1 cubed plus a2n plus 1 squared plus a1n plus 1 plus a0 equal to wn plus 2, which is a3n plus 2 cubed plus a2n plus 2 squared plus a1n plus 2 plus a0. And then plus wn, if you replace again from here, it will be a3n cubed plus a2n squared plus a1n plus a0, okay? Minus 2an minus 2b. Now, what should we do? Okay, now we know this is correct for n infinity many n and the degree 3. We want to apply this rule. Let me call it, for example, it is as lemma or idea or anything like that. So let's consider n cubed is what here? The coefficient of n cubed. So first, let's write it as a3 n cubed plus 3n squared plus 3n plus 1 plus a2 times n squared plus n plus 2n, sorry, plus 2n plus 1 plus a1 times n plus 1 plus a0, okay, equal to, now let's write this term, a3 times n cubed plus 3 times 2, 6, n squared plus 3 times 4, 12n plus 8 plus a2 times n squared plus 4n plus 4 plus a1 times n plus 2 plus a0 plus an cubed, a3n cubed plus a2n squared plus a1n plus a0 minus 2an minus 2b. Okay, let's consider coefficient of n cubed. So on left side it is this one 2a3. On right side it is what, a3 here plus a3. So 2a3, it is okay. Now let's consider coefficient of n squared. 3 a3 2 6a3 plus a2. Here it will be 6a3 plus a2 plus a2 here again. So it will be 6a3. Let's consider a2. Sorry. a2, we have 2 also here. So 2a2, a2, a2, 6a3, 6a3. Now let's open a new page. Let's consider coefficient of n. Here 3a3, 2, 6a3 plus 2 times 2, 4a2 plus a1 times 2, 2a1. Now here, if we consider 6a3 So coefficient of n. 12a3 plus 4a2 plus a1 plus a1 again minus 2a. Okay, so 6a3 here, 12a3. So we can simplify here. 6a3 will be left. 4a2 we can cancel. 2a1 we can cancel. We can take negative 2a to left hand side. It's 2a. So we can say a equal to 3a3 if we don't have careless mistake. The solution is similar to this, okay? So because we should find answer in terms of a and b, so a3 is a over 3. This is the first thing. And at the end, we should check. Coefficient of constant term. Here it is 2a3, 2a2, plus 2a1, plus 2a0, which is 8a3, plus 4a2, plus 2a1, plus a0, plus a0, minus 2b. Okay? Now, if we consider these constant terms, a3, 8a3, 6a3, we've considered this and this. 4a2, it will be 2a2, 4a2 minus 2a2. 2a1 will be cancelled. 2a0 will be cancelled. Minus 2b. So it is equal to 2b. And we know a3 is a over 3, so 6a3 is 2a plus 2a2. So if you divide by 2, b equal to a plus a2. So we conclude a2 is b minus a. Okay, so we found a2. To satisfy, so if we consider these two values, these conditions will be satisfied. Only we should consider these two equations. Let's copy from these two. Okay, let's paste it here. W1, A3, A over 3, plus A2, B minus A, plus A1, plus A0, 0. 8A3, 8A over 3, plus 4A2, plus 4B minus 4A, plus 2A1 minus plus A0, 0. Okay. Now here, we want to find A1. If we subtract second one minus first one. So 8a3 minus a3 will be 7a3. 4b minus b, 3b. Negative 4a minus minus a, negative 3a. Plus 2a1 minus a1, a1. Plus a0 minus a0, 0. So 7a3 minus this. So a1 equal to 3a minus 7a over 3 minus 3b. So it will be 9a minus 7a is 2a minus 3b. And a0 is what then? A0 from first one is a negative a1 minus b plus a minus a over 3. Negative a1 is what? Negative 2a over 3 plus 3b. Minus b plus a minus a over 3. A minus a over 3 is 2a over 3. Will we cancel with this? 3b minus b is 2b. So a0 is 2b. So we found all coefficients. You can check that, okay? If the last answer is not correct, only careless mistake, okay? I can check it for you. And says given W1 equal to W2 equal to 0, we've considered find W in terms of A and B. So we found all coefficients, A3, A2, A1, A0 in terms of A and B. You can check in and replace these things in terms of A and B. So the whole solution is this. And we solved this problem completely. Okay, let's consider we have another problem related to telescoping rule. This problem from M.Sc. Okay, problem 18 says a function we want to solve again with recursive sequence. Also, I will tell you some ideas after this problem. A function f is defined recursively by f of 1 equal to f of 2 equal to 1 and f of n equal to f of n minus 1 minus f of n minus 2 plus n. For all integers n greater than or equal to 3, what is f of 2018? So here, when you see problems like these, in the first view, we cannot use telescoping rule. But if you use f of n minus 1 here, it will be f of n minus 2 minus f of n minus 3 plus n minus 1. If you use f of, so if you add, it will be f of n plus f of n minus 1 equal to this part will be cancelled. If you add, it will be f of n minus 1 minus f of n minus 3 plus 2n minus 1. Now you can cancel these two things. And then you will see f of n equal to negative f of n minus 3 plus 2n minus 1. Also, we can say f of n minus 3 if we use the same formula, minus f of n minus 6 plus 2n minus 6 minus 1 minus 7. So if you replace it here, it will be negative of that. It will be plus fn minus 6 and minus 2n plus 2n will be cancelled. Minus minus 7, 7 minus 1, 6. Now that's good. Fn, if you solve some problems with telescoping rule, when you see this, it is so much good. We can write this. Now the problem says f of 2018 is what? From here, we know that f of n, we can write it like this and apply telescoping rule equal to 6. So f of 2018 minus f of 2012 equal to 6. Then we can write f of 2012 minus f of, if we subtract 2006 equal to 6 again. Next one, f of 2006 minus f of 2000 equal to 6. So if we consider these numbers, because we subtract by 6, and the remainder when divided by 6 is constant. If we divide with 321, 338, 6, the remainder is 2. So last part is f of 8 minus f of 2 equal to 6, and previous part is f of 14 minus f of 8 equal to 6. So here, 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 here. And then we can conclude f of 2018 minus f of 2 equal to what? 6 times the number of them. So let me tell you a way to find the numbers here. 2, 8, 20, 12, arithmetic progression. We say last one minus first one, 2018, minus 2 over common difference, which is 6 plus 1. F of 2 is what the problem says. F of 2 is 1 here. Okay, f of 2 is 1. So f of 2018 equal to 2018 minus 2 is 2016. So 6 times that will be 2016 plus 6 times 1, 6, minus 2 plus 1. So it will be 2023. So the answer will be, I think we had a careless mistake. So let's check it again. This one, 6 f of n f of 2018. Oh, sorry. Here, 2012. So 2012 minus 2, which is 2010. So we should correct it. 2010 plus 6 plus 1. It will be 2017. Okay, so let's see which choice is the answer. It is B. Okay, so we saw, let me tell you as homework 2 things. The first part, find closed form. Okay, these are good techniques that are useful in BMO, many Olympiad exams, in steps, problem, and for applying university. The first one is an equal to 2an minus 1 when we have a constant plus 3. And for example, a1 is 2. Then find closed form of an when we have constant coefficient. Part B, an equal to an minus 1 plus 3. Plus, let me tell you, n minus 2 factorial a1. Now I want to tell you a hint for these problems. So if you want to focus on them, you can skip this part. And if you couldn't, you can pause the video and try to solve these 2 things. And then if you couldn't, you can see these hints. You should define bn equal to an over 2 to the n. And then you can find bn, the coefficient for bn will be 1. You can find closed form of bn, then find an. For this one, you should define another bn. Again, pause the video and try first on your own. You should define Bn equal to An over n factorial. It means for these two parts are these things. Okay. If you wanted to learn more from this topic or wanted to solve more problems, we have many problems in all Olympiad exams applying university that can be solved with these things, polynomials, recursive sequence that you should find close for telescoping rule and something like this. In AMC 2022 we had and many AMC 10. Many exams from basic level to hardest level. Also in IMO we need to know telescoping rule. So as I say, if you wanted to learn more ideas or focus on this idea, you can send message to my WhatsApp number. The next problem is concerning small exam by induction. I released a video related to this problem. You can see that in my channel. Also, I released a solution of this. You can see in my channel. For this one, let's solve because it is PMO2 2022. So I've not released the solution of this problem. Let's solve first together. I don't think I released. Maybe I released, but let's do one problem from this topic. Okay, VM around 2022. It says for a given positive integer k, we call an integer n a k number. If both of the following conditions are satisfied, the integer n is the product of two positive integers which differ by k. The integer n is k less than a square number. Find all k such that there are infinitely many k numbers. So let me tell you something first. You should try this problem at least for 30 minutes. If you try for 1 hour, 2 hours, it will be better. Because when I tell you the answer, if you've not worked on that first on your own, the solution, understanding the solution will be so much harder. So here, I want to use small examples, k1. If k is 1, you say okay. But first part, the integer n is the product of two positive integers differ by k. So a times a plus k, both of them are positive integers. And the problem says k is also positive integer. So here you will understand n also has to be positive integer. And the integer n is k less than a square number. So n is b squared minus k. B has to be again positive integer because it is minus k, n is positive integer, k is positive integer, b has to be positive integer, b squared has to be positive integer. So we can also say b has to be positive integer here because if it is negative, you can say without loss of generality. And it cannot be zero, so we can say without loss of generality. It is this. And a square number means b should be integer in general. Find all k such that there are infinitely many k numbers. So let's check k1 first. N should be a times a plus 1. Also, it should be equal to b squared minus 1. So a times a, it is a squared plus a equal to b squared minus 1. Then if you add 1, a squared plus a plus 1 equal to b squared. And then here we can say something. A squared plus a plus 1 is greater than a. This idea is so much useful. Considering between two consecutive perfect square. And by this idea, you can solve one problem of promise. Last promise 2022. Also in 2023, I think we had that problem. It is one of the most prestigious summer camps. We have SUMAC, which is for Stanford, and you can apply for SUMAC promise. They are good for your CV. You can, for example, pass the exam. If you couldn't, some of them are online, some of them are in person. But if you can't participate in them, you can try the problems, and if they accept you, it will be so much good for your CV. Okay. Now a squared plus a plus 1. Let's say a plus 1 squared. Why? Because it's a squared plus 2a plus 1. Obviously, it is correct. So when a number, it should be what? It should be b squared, like here. When a number, for example, b squared, is greater than 5 squared, less than 6 squared, two consecutive perfect squared, b squared cannot be perfect square. So here we reach contradiction. So k1 is not good. K2, n equal to a times a plus 2 equal to b squared minus 2. So we can say a squared plus 2a. We can add 2 plus 2 equal to b squared. Again, can you tell me this number again is between which two consecutive perfect squares? The left side is a plus 1 squared and right side is a plus 2 squared. Let's see why. A plus 1 squared is a squared plus 2a plus 1. And it is equivalent that 1 is less than 2, which is correct. And this one is a squared plus 4a plus 4. And if you simplify, 0 is less than 2a plus 2. Because a is positive integer, this one also correct. Again, here contradiction. Because this one should be perfect square, b squared, but it cannot be between two consecutive perfect squares. So let's check K3 in next step. So what can we say here? N equal to a times a plus 3 equal to b squared minus 3. So it will be a squared plus 3a. If you add 3 plus 3 equal to b squared. And can we consider it between two perfect square? Try to find them first on your own. This one is a plus 1 squared, this one a plus 2 squared. It will be a squared plus 4a plus 4, which is obviously greater than this, and this one is a squared plus 2a plus 1. Now let's check K4. N is a times a plus 4. A times a plus 4 equal to b squared minus 4. And then it will be a squared plus 4a plus 4 equal to b squared. This one will be a plus 2 squared equal to b squared. So we will see there are infinitely many a's that satisfy many k numbers. Why? Because, for example, if a is 1, then n equal to 5. If a is 2, 1 times 5. N equal to 2 times 6, 12. Why? Because it is 1 times 5. Difference is 4. Also, it is b is a plus 2. It is 3 squared minus 4. This one is what? 2 times 6. Also, it is 4 squared minus 4, and so on. Okay, so K4 is the first answer that we found. From here, you can consider general 4. Okay? So, for example, suppose we want to find K, but we should consider two cases for K. Let's write first n equal to a times a plus k equal to b squared minus k. So again, a squared plus ak plus k equal to b squared. So we should consider two cases first. And we can say n is at least what? N is at least 5 because we've checked k, k is at least 5 because we've checked 1 to 4. So the first case you say k is even and case 2k is odd. So in first case that k is even, k is 2q. And here you say a squared plus 2qa plus 2q equal to b squared. We can say it is greater than a plus q squared. Let's check. A plus q squared. No. This one is better to write a plus q minus 1 squared. And this one a plus q squared. So let's see. This one is a squared plus 2aq plus q squared. So if we want to say is it correct or not, a squared 2qa will be cancelled. So 2q should be less than q squared. And this one is equivalent if you divide by q because q is positive. Q is greater than 2. And because k is at least 5, so for even numbers k is at least 6, so q is at least 3. Okay, it is correct. Now let's consider this part. It will be a squared plus 2aq minus 1. Okay, 2aq minus 1 plus q minus 1 whole squared. Why it is less than this? A squared plus 2qa plus 2q. We want to prove it. So 2aq will be cancelled. So negative 2a, we take it to right side 2a and left side q minus 1 squared minus 2q. This part is constant. And the problem says prove that there are infinitely many good k numbers. And here, so you should prove there are infinitely many a's that are good. But for some point after some a's, we have these two inequalities. It will be greater than this a. And then we can say after that a, this number is between two consecutive perfect square and contradiction. So it is not good. If you had question about the proof or anything else, as I said before, feel free to send message to my WhatsApp number in the description and comments. Now let's consider case 2, which k is odd. And we know that k is 2q plus 1. Let's consider, for example, 2w plus 1 to not have mistake with previous one. And w is at least 2 because k is at least 5. We've checked 1 to 4. And then again, a squared plus 2q plus, look, ak plus k plus 2w plus 1 times a plus 2w plus 1. Now here is less than what greater than 1. We can say it is a plus w squared, a plus w plus 1 whole squared. So if we check that, left side will be what? It will be a squared plus 2aw plus w squared less than a squared plus 2wa plus a plus 2w plus 1. We can cancel. We can cancel. Again, a will be greater than w squared minus 2w minus 1. Again, this part is constant, and if we have infinitely many a after some point, we have this inequality. Because a increase to infinity, but this one is constant. Next part, again, we write a squared plus 2wa plus a plus 2w plus 1 is less than this part. A squared plus 2a times w plus 1 plus w plus 1 squared. 2aw plus 1, 2, this part will be cancelled. A squared will be cancelled. Oh, sorry. This one is 2aw plus 2a. So we can cancel this, but a and 2a, it will be a. We've considered this one. And a squared will be cancelled. It is greater than minus w plus 1 squared plus 2w plus 1. And if we consider, it will be negative w squared minus 2w minus 1 plus 2w plus 1 grade a. So it will be this one, this one, this one, this one. Why a is greater than negative w squared, which is correct because here is a negative number. So we can say what? We can say again, this one is bad because after some a, after a greater than some number, we have this inequality, and it is not possible that b squared between two consecutive perfect squares. So the only k that is good is k4. Okay, we've solved one problem from this idea, and as I told you, I solved this problem in my channel. You can see my previous videos. Next one, ideas in absolute value. With respect to our time, I should absolute values, I should ignore some parts to have time. For some ideas in areas, perpendiculars, I should solve some important parts. Let me see which of them important. Vieta's formula is so much important. Newton's sum. And you have problem of Stanford. Also on this part is important. So let's solve these two ideas and then finish. But the previous ideas, and I wrote similar problems. For example, this problem I released Amy 1 2023 last Amy in my channel. You can use. If you had question about these problems, I've written all these things. You can try on your own. And if you had question, as I said before, feel free to send message to my WhatsApp number in the description comments. Now let's focus on Vieta's formula and Newton's sum. This problem is from step 2 2021. Problem 2, let's solve it. It says in this question the numbers a, b, c may be complex. First part, let p, q, and r be real numbers given that there are numbers a and b such that a plus b p, a squared plus b squared q, and aq plus bq equal to r. Show that 3pq minus pq is 2r. Here is only replacements. So let's do it. So let's replace 3pq is what is 3a plus b, a squared plus b squared minus p cubed. P cubed is what a plus b cubed. Why it is equal to 2r. We want to prove it. 2a cubed plus b cubed. Here, this one will be what? Will be 3a cubed plus 3ab squared plus 3a squared b plus 3b cubed. Minus this part will be a cubed plus 3a squared b plus 3ab squared plus b cubed y is equal to 2a cubed plus b cubed. 3a cubed minus a cubed will be 2a cubed. 3ab squared 3 minus 3a ab squared will be cancelled. 3a squared b 3a squared b will be cancelled. 3b cubed minus b cubed is 2b cubed equal to 2a cubed plus b cubed. Okay. So this one is correct, this one is correct, this one is correct. It is part 1. We've solved completely. Let's solve next parts. Part 2. It says conversely, you are given that the real numbers p, q are satisfying this by considering the equation this. Show that there exist numbers a and b such that the three equations in star hold. Let's check it. For this part, we know when the degree is 2. It is a special case of Vieta's formula. For degree 2, let me write. For degree 2, we can call it as a lemma. when we have ax squared plus bx plus c, if the roots are r1, r2, you can write it as x minus r1, x minus r2. For greater degree also we use same thing, Vieta's formula. So then you consider coefficient of x squared. On left side is a, on right side is a. Coefficient of x on left side is b, on right side it is a times minus r1 minus r2. So we can conclude sum of roots r1 plus r2 is negative b over a. And if you consider coefficient of constant term, for constant term c equal to a r1 r2. So product of roots r1 r2 equal to c over a. And here it says, okay, PQR are these, considering the equation these, show that there exist numbers a and b such that the three equations hold. These three equations. Okay, so here some of the roots, let's consider some of the roots r1 plus r2 is what? By this formula, negative b over a. So negative 2p over 2, which will be p. r1 times r2 is p squared minus q c over a. P squared minus q over 2. The problem says r1 plus r2 is p. A and b are the roots. Then it says r1 squared plus r2 squared is q. We should prove it. r1 squared plus r2 squared equal to what? Here it is equal to r1 plus r2 whole squared minus 2r1 r2. Also with Newton's sum we can solve this, but in some problems you have to use Newton's sum. If in this problem we could solve it without Newton's sum, we solve it. If you want to know exactly Newton's sum is what, I explained this in my previous video, but if you had question, feel free to send message to my WhatsApp number in the description comments. Okay. r1 plus r2 squared is p squared minus 2 times this, which will be minus p squared plus q. It will be q. As you can see, r1 squared plus r2 squared is q. Now we should calculate r1 cubed plus r2 cubed. Now r1 cubed, let's write it here. r1 cubed plus r2 cubed. By using identities, it is r1 plus r2 cubed minus 3r1 r2, r1 plus r2. r1 plus r2 is what is p? It will be p cubed minus 3. This one is p. r1 times r2 is p squared minus q over 2. Now we should prove it is what? We should prove it is r. So for proving that it is r, we multiply both sides by 2, 2p cubed minus 3. P cubed plus 3p cubed equal to 2r. And then if we cancel, it will be 3p cubed minus p cubed equal to y, it is 2r. So let's see, 3p cubed minus p cubed equal to 2r. We know by assumption of the problem it is correct. So we proved our a and b. A is r1, for example, b is r2, the roots. Okay, here we've used only Vieta's formula for degree 2. And without also Newton's sum, with identities we could solve. Now let's solve this one. Part 3. Let S, T, U, and V be real numbers given that there are distinct numbers A, B, C such that we have these equations. Show using part 1 that C is a root of the equation this, and write down the other two roots. So it says show using part 1 that C is a root of equation. Okay, when we want to prove that C is a root here, so if we replace x with C, it should be 0. So we should prove 6c cubed minus 6sc squared plus 3s squared minus t times c plus 3st minus s cubed minus 2u equal to 0. Okay. It says using part 1. Part 1 was what? It says a plus b, if a plus b cubed, we have this. Here, let me tell you how I want to prove. I will prove without this way. I will prove with Vieta's formula for degree 3. Let me tell you, if we have ax cubed plus bx squared plus cx plus d, and the roots are r1, r2, r3, we can write it like this. And again, if we consider coefficients of x cubed on both sides, it is a. If we consider coefficient of x squared, on left side it is b, on right side it is a times negative r1 minus r2 minus r3. So sum of the roots r1 plus r2 plus r3 equal to negative b over a. And if you consider coefficient of x on left side is c, on right side is a, r1 r2 plus r1 r3 plus r2 r3. And then we can conclude this part is r1 r2 plus r1 r3 plus r2 r3 equal to c over a. And last part, if we consider constant terms, d equal to a times negative r1, negative r2, negative r3, which will be negative r1, r2, r3. So r1, r2, r3 is negative d over a. Now, if we use this formula here, suppose our roots are what? X 6 times x minus r1, x minus r2, x minus r3. So it was only a point, and A, B, C in the problems are different. Let me show a rectangle like this. Okay, so let's check it. Here, we can say, if we have these roots, r1 plus r2 plus r3, by this formula, it is negative b over a. So it is negative 6s over 6, which is s. r1, r2 plus r1, r3 plus r2, r3 equal to c over a, which is what? This over a. So this one over a. So it is 3s squared minus t over 6. So it will be what? It will be 3 over 6 is 2. So it is s squared minus t over 2. And r1, r2, r3 equal to this part over 6. So it will be what? It will be 3st and negative of that. But here negative. So I can write it as s cubed plus 2u minus 3st all over 6. Okay. Now, and I want to tell you that as you can see, r1 plus r2 plus r3 is s. I want to find r1 squared, r2 squared, r3 squared here. Okay. And here we calculate something. It says s cubed minus 3st minus plus 2u is 6b. So if you replace 6b over 6, it will be b. And here we have ABC. And now, if I want to find r1 squared plus r2 squared plus r3 squared, let me write it here. r1 squared plus r2 squared plus r3 squared equal to r1 plus r2 plus r3 squared minus 2 times r1 r2 plus r1 r3 plus r2 r3. And we know sum of the roots equal to what? Equal to s. And 2 times this is s squared minus t. Is s squared minus t, which will be t. And here we will see, okay, it is okay, it is okay. Now, a cubed plus b cubed plus c cubed. Okay, so let's calculate that. r1 cubed plus r2 cubed plus r3 cubed. You can use here Newton's sum, or we can use a famous identity that is r1 plus r2 plus r3 times r1 squared plus r2 squared plus r3 squared minus r1 r2 minus r1 r3 minus r2 r3 plus 3r1 r2 r3. r1 plus r2 plus r3 is what here? S. r1 squared r2 squared r3 squared t minus this part is here. It's minus s squared minus t over 2. 3r1 r2 r3 is what? Is s cubed plus 2u s cubed plus, so let's consider by 3 when we multiply. S cubed plus 2u minus 3st over 6 times 3 over 2. Okay, so it will be what? It will be st minus s times s squared minus t over 2 plus s cubed plus 2u minus 3st all over 2. So if we use common denominator 2, it will be 2st minus s cubed plus st plus s cubed plus 2u minus 3st. Minus 3st with this part cancel, 2u over 2u. So it's u. And now it says prove that ABC and ABC equal to V, it says. So we will see this part. So R1, R2, R3 satisfy this part, and this part. Okay. So R1, R2, R3 are ABC determined, and the roots are here ABC. And it says ABC, and we have a unique polynomial that have these roots because it satisfies these three equations. And it says ABC equal to V. Now, because we know ABC are R1, R2, R3, here we can say S cubed plus 2U minus 3st over 6, which is R1, R2, R3 equal to V. So if we multiply by 6 both sides, S cubed plus 2U minus 3st equal to 6V. So we proved also this part, and other two roots also are B and 6. So we've solved also part 3. For part 4, it says find numbers ABC such that we have this, and verify that your solution satisfies the 4 equations in double star. Okay, so for this one, we want to create a polynomial that the roots are this. So we know a plus b plus c is 3, so we want to find ab plus ac plus bc first, which is a plus b plus c squared minus a squared plus b squared plus c squared all over 2. So it is 3 squared minus 1 over 2. 9 minus 1, 8 over 2, 4. Now last part we want to find ABC. And the problem says ABC is what? If we want to create a polynomial that works like this, we say, okay, it is x cubed, for example, minus a2x squared. Let's write like this, a2x squared plus a1x plus a0. Like Vieta's formula, we know it is x minus a, x minus b, x minus c. We know that a plus b plus c is negative a2 because a1 is 1, a3 is 1. A, B plus AC plus BC equal to coefficient of x, which is A1. ABC is negative A0. Or, yes, that's good. A plus B plus C is 3, so A2 is negative 3. AB plus AC plus BC equal to 4. A1 is 4. ABC equal to 2 here, so A0 is negative 2, and we can say, okay, it is what? It is x cubed minus 3x squared plus 4x minus 2 equal to 0. Now, we want to find one root. If we replace for example with 1, it is good, because if x is 1, then it will be 1 minus 3 plus 4 minus 2. 2 minus 2, 0. So x1 is one root. Okay? And let's also consider previous part. One answer is 1. Here, if we replace x with 1, it will be 6x minus 6 minus, let's check it, 6 minus 6x plus 3s squared minus 3t plus 3st minus s cubed minus 2u. So negative 6s, s cubed minus 3st plus u. Plus 2u here. This one will be 0, we proved. And 3s squared minus this part. Okay, no. I just wanted to check that. Did we have 1 as a root here? No, not necessarily. Okay, because x has one root, we can factorize. One factor is x minus 1, then we place x squared to create x cubed minus x squared, we place minus 2x, plus 2x, we place plus 2 minus 2, 0. And then our roots, it says verify your solution satisfy the 4 equations. So one answer is x1 here, or this part is 0. If you use quadratic formula, it will be 2 plus minus b squared 4 minus 4 times 2, 8 over 2. So it will be 2 plus minus negative 4, which is 2i over 2. So it will be 1 plus minus I. So another 2 roots here. So we have 3 roots for this problem. We found ABC. Okay, so ABC are 1 and 1 plus minus I. And we can check, for example, some of them will be 3. It will be correct. Also, you can check other parts. Product of them will be 2 times 1 is 2. Okay, so we've solved this problem completely with Vieta's formula. Also, we could use Newton's sum. But we've solved with simpler ideas. If you want to know, as I said, Newton's sum, or want to solve more problems, I solved this problem in my previous videos. You can check my channel. Also, this problem, I released a solution. If you had question about this topic, or wanted to solve more problems, or wanted to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. Here, for integer part, we have one problem from a step 2 2020, one from problem from AMC, one problem from PMO, another problem from AME. Okay, for problems in integer part, one useful way, an important way. At first, you think it's simple, but we can solve so much hard problems. You write x as k plus r, which k is integer part, and r is fractional part, which is between 0 and 1. And then in many problems, we should use quadratic formula and something like that. So this one is integer part, and this one is fractional part. So with respect to our time, I solve as much as we can. Then you can try rest as homework, and also if you have questions, you can feel free to send message to my WhatsApp number in the description. Okay. It says it defines, for example, integer part is what, fractional part is what. Then it says solve the simultaneous equations. This floor of x plus fractional part of y equal to 4.9, fractional part of x plus integer part of y equal to negative 1.4. So here when we write something like this, we know the only possible for this that integer part is 4 and this 0.9. Why? Because for example, if it is 3, then it will be 1.9 greater than 1. Or if it is, for example, 5, then it will be negative. So the only possible case for this is this one or this one, because fractional part always is between 0 and negative 1 and 1 less than 1, and integer part is in here these numbers are integer floors, so the only possible is this and x 0.6. So now x will be what? 4 plus 0.6, 4.6, and y is what? Negative 2 plus 0.9 will be negative 1.1. Okay, so here we found these two answers for first part. Now let's solve second part. Part 2, it says given that x, y, z satisfying the simultaneous equations, these three equations, x plus integer part of y plus fractional part of z, equal to 3.9, fractional part of x plus y plus integer part of z equal to 5.3. Last equation, integer part of x plus fractional part of y plus z equal to 5. So how can we solve this problem? We want to find, it says show that fractional part of y plus z equal to 3.2. Here first we write, as I said, the most important idea. We divide each number to fractional part plus integer part. So x equal to integer part plus fractional part. And also we can write for y and z. If we use for first one, it will be integer part of x plus fractional part of x plus fractional part of y plus fractional part of z equal to 3.9. And the next one is we can write as, I forgot to write integer part of y also. So let's write integer part of x plus integer part of y, fractional part of x, plus fractional part of z equal to this. Now for next one, if you write y as fractional part of y plus integer part of y, it will be integer part of y plus integer part of z, okay, plus integer part of y and z, and fractional part of y and x plus fractional part of x and y equal to 5.3. Integer part of x plus integer part of z, integer part of x plus integer part of z plus fractional part of z plus fractional part of y and fractional part of z equal to 5. Okay. So now here it says consider integer part of z and fractional part of y. So if we want to consider this equation, it's good because we want to only have integer part of z. So if we add these two, let's call this one first one, second one, third one. because we want to find z. This plus this minus this. So 2 plus 3 minus 1. So 2 plus 3. X plus y minus 1 will be cancelled this part. So we have 2 times integer part of z. Let's focus on fractional part. Xz, it will be cancelled here. 2y plus 2y equal to 2 plus 3, 5.3 plus 5, 10.3, minus 1, which is 3.9. So 3.9 is what? Is 6.1, 6.4. And if you divide by 2, this one plus this one equal to 3.2. Okay, so we've solved this one, and then it's just solve the equations. Okay, so if we do the same thing, if we consider 1 plus 2 minus 3, let's see what we have. Xz will be cancelled. We have 2y, integer part of y. And zy will be cancelled, plus 2 fractional part of x equal to 3.9 plus 5.3. It's 8, 8.9, 9.2. Minus 5 equal to 4.2. So it will be fractional part of y plus integer part of y plus fractional part of x equal to this divided by 2. It's 2.1. Now, the next one. 1 plus 3 minus 2. So this plus this minus this yz will be cancelled. 2x, 2 times integer part of x. This plus this yz, xy will be cancelled, plus 2z. Fractional part of z equal to 1 plus 3, 8.9, minus 5.3. So if we subtract, it will be 6 here. 8 minus 5, 3. Okay, so we have these equations. Let's write all of them. Okay. So here, because it is fractional part like part 1, we can find integer part. Here is 3. The only possible case 0.2. Here is 2. It's 0.1. And here, when we divide by 2, x plus z equal to 1.8. And this, fractional part of z. So if we consider fractional part of z here, it's 1 and it's 0.8. Now, x will be what? Integer part plus fractional part 1, 1.1. Y is what? 2 plus fractional part 2.2. And z is what? 3.8. Okay, so we found x, y, z here. Our answers are these. We can check to not have any careless mistake. Okay, let's check only one equation. X plus integer part of y, 1.1 plus integer part of y plus fractional part of that, which is 0.8, which is 1.9, 2.9, 2 plus 1.9, 3.9. Okay, so it will be 3.9 and it is okay. Okay, you can check also other terms. So we've solved part 2 completely. Now let's solve part 3. It's a solve the simultaneous equation. Again, we use the same thing for x, y, z. Each of them we write as fractional part, integer part plus fractional part. So the first one will be integer part of x plus 2 times integer part of y plus fractional part of x plus fractional part of z equal to 3.9. And then here, 2 times integer part of y plus integer part of z equal to 2 times fractional part of y plus fractional part of x equal to 5.3. X integer part of x plus integer part of z plus 2 times fractional part of y plus fractional part of z equal to 5. Again, here we should see how we can cancel these things. So let's first subtract this minus this. This one will be cancelled. So integer part of z minus integer part of x. This minus this one will be cancelled, plus 2 times y minus integer fractional part of z equal to 5.3 minus 3.5. 9 here is minus 4, 1.3, 1.4. Okay. Now, if we consider this one and third equation, if we add minus x will be cancelled, it will be 2 times integer part of z plus 4 times fractional part of y equal to 5, 6.4. And then integer part of z plus 2 times fractional part of y equal to 3.2. So here we have two cases. If this one is 3, this one is 0.1. If this one is 2, then this one is 0.6, okay? So we have two cases like this. Now, let's consider first case. Let's check 2, 1.2. Yes, the only possible cases are these, because if it is 1, then it's not possible. Okay, so let's replace first one. In case 1, this is 3, and this one is 0.1. So in first equation, we don't have any important thing. In second equation, it is z 2 times fractional part of y plus fractional part of z3 plus 2 times this 0.2 plus x equal to 5.3. And then we can subtract, it will be 2 times integer part of this plus fractional part of x equal to 3.2 minus 5.3 minus 3.2. So 5 minus 3, 2.3, 2.1. Okay. Now here, the only possible case, it is 0.1. The only possible case then for this is, because it is integer, it is fractional part. This one has to be 1. Okay. So in this case, we've concluded that integer part of y is what? Fractional part of x is 0.1. And if you consider last one, integer part of x plus integer part of z plus 2 times fractional part of this is 0.2 plus fractional part of z, which is what do we have? No, equal to 5. So here, integer part of x plus fractional part of z equal to 5 minus 3, 2. 2 minus 1.8. So this one is 1, this one is 0.8. So for this problem, in this case, x is what? 1 plus 0.1, 1.1. For y, it is 1, 1.1. For z, it is what? It is 3, 3.8. Okay. Now let's consider our three equations. Okay, for first one, x 1.1 plus 2 times this integer part plus fractional part 0.8. If we add, it will be 2 plus 1, 3, 3.9. The first one is correct. Second one, fractional part of x is 0.1 plus 2 times the y, which is 2.2, plus integer part of z, which is 3. 3 plus 2, 5, 5.3, which is correct again. Third one, integer part of x, which is 1 plus 2 times fractional part of y plus z, which is 3.8. It's 4, it's 5, so it's correct. So one answer are these x, y, and z. Now, let's solve case 2. In case 2, we said what? Integer part of z is 2 and fractional part of y is 0.6. Is 2, fractional part of y is 0.6. Again, let's consider these two equations. Let's copy and paste them. Okay, so for first one, we say 2 times integer part of y plus integer part of z2 plus 2 times this 1.2 plus x equal to 5.3. So this part is 3.2. So 2 times this part plus fractional part of x equal to 2.1. And if you consider the cases, because it is integer, it is 0.1, and this one has to be 1. Okay. Now let's consider next one. Integer part of x, we write it. We've not calculated so far. Integer part of z is 2. Plus 2 times fractional part of y. We write 2 times fractional part of y. Plus in the fractional part of z, fractional, let's check. A fractional part of y, we know it's 2 times 0.6 is 1.2. Plus fractional part of z equal to 5. Okay, so this one is what? It's 3.2. So integer part of x plus fractional part of z equal to 1.8. So this one is 1, this one is 0.8. Now, here, x will be what? Integer part of x plus fractional part is 1.1. Y is what? Integer part 1 plus fractional part of y 1.6. And z is integer part of z plus fractional part of z 2.8. Now again, we want to check for these three equations. Okay, let's check first one. X is 1.1 plus 2 times integer part of y, which is 2, plus fractional part is 0.8. It's 233.9. It is correct. Now, next one. Fractional part of x, which is 0.1 plus 2y, 3.2 plus fractional part of z, which is 2. It's 5.3. It's correct. And fractional part, integer part of x is 1 plus 2 times fractional part of y is 1.2 plus z 2.8. So here it will be 3.5. It's correct. Okay. So we found two parts of solution. All of them we've solved with same idea that in this types of problem we should divide a number into integer part and fractional part. Again, for this problem of AMC, for this problem of PMO, Philippine Mathematical Olympiad, and for this problem of AME, that is so much hard. This one so much harder than problem of step, but same idea. For all of them, you should use the same thing. Also here, you should use first a small example. But a small example on what? If you want to learn that and want to prepare yourself for applying top universities, for participating in Math Olympiad exams, prestigious for America, AMC, AME, USAMA, for IMO, International Mathematical Olympiad, for BMO, British Mathematical Olympiad, or any math exams. If you want to prepare yourself, want to learn important ideas that are useful in many exams, as I said before, feel free to send message to my WhatsApp number in the description comments to learn 40, 50 important ideas in each topics. Okay, thanks for watching this video. Have a nice day. Bye.